There's a paradox sitting on shelves in classrooms, workshops, and kitchens everywhere. A bottle of glue is designed for one specific purpose: to permanently bond objects together. It's supposed to stick. That's literally its entire reason for existing. Yet somehow, despite this singular purpose, glue consistently fails to do what it's meant to do to the one surface it's in constant contact with, the interior of its own bottle. You can store a bottle of glue for months, even years sometimes, and it won't form a solid mass. It won't bond to the plastic walls. It remains liquid and usable, waiting patiently inside its container. But the moment you squeeze even a tiny drop onto paper or wood, it springs into action. It begins the transformation from liquid to solid. It sticks. This seems almost impossible. How does glue know when to be sticky and when to remain liquid? Is there some intelligence involved? Does the glue have the ability to choose? The answer, fortunately, is far more interesting than magic, and it reveals something fundamental about how chemistry works. Most people assume glue is constantly sticky because that's the experience they have with it. You squeeze some out, it feels tacky, and it bonds things together. It seems logical that glue must always be trying to stick, always reaching out, chemically speaking, to attach itself to anything nearby. But this assumption is wrong. The truth is that most common household glues aren't sticky at all until something triggers the adhesion process. Let's examine white school glue, the kind you probably used in elementary school. Inside that plastic bottle is not pure adhesive. Instead, it's a mixture of tiny plastic-like particles suspended in water. Think of it like a liquid that contains solid specks floating throughout. While the glue remains in the bottle, these particles are separated from each other, suspended in that watery medium. The water acts as a carrier, keeping everything in a fluid, usable state. The glue isn't attempting to harden or bond. It's simply waiting in its liquid form, stable and inactive. The key to understanding why glue doesn't stick inside the bottle lies in understanding what actually triggers adhesion. For most traditional glues, the answer is surprisingly simple: air and evaporation. When you squeeze glue onto a surface and spread it around, you've just exposed it to the atmosphere. The water inside the glue begins to evaporate almost immediately. As that liquid portion escapes into the air, something crucial happens. The plastic particles that were suspended in the water are forced closer and closer together. They begin to compress and interact. Eventually, these particles form a solid layer that grips and bonds to the surfaces around it. But inside the bottle, none of this occurs. The cap seals the container. The environment is closed off from the atmosphere. Without air exposure, water cannot evaporate efficiently. The glue remains in its original liquid state. Since evaporation never happens, the particles never compress, the bonding process never triggers. The glue stays glue instead of becoming a solid adhesive. Think about what's happening chemically. The bottle isn't preventing glue from sticking through some mysterious property. It's simply preventing the conditions that would cause sticking from developing. Remove the oxygen exposure, remove the evaporation, and you've removed the catalyst for adhesion. It's not that glue is smart enough to avoid bonding to plastic. It's that the bottle creates an environment where bonding simply cannot occur. The material of the bottle itself contributes to this phenomenon as well. Manufacturers carefully select plastics for glue bottles because they know which materials work best. Most glue bottles are made from plastics that have minimal interaction with the adhesive inside. Imagine the opposite scenario. If you poured glue into something highly porous and absorbent, like cardboard, the liquid would immediately begin soaking into the fibers. The glue would start drying right away. But plastic has a smooth, non-absorbent surface. Water doesn't soak into it easily. The glue remains as a liquid layer rather than spreading into the material and beginning the drying process. It's similar to how water beads up on a car window. The surface just doesn't encourage strong attachment. So, Why doesn't super glue harden inside its tube? The answer involves careful manufacturing control. Manufacturers minimize moisture exposure during packaging and sealing. They use specialized containers and processes to keep water vapor out. As long as moisture stays away from the cyanoacrylates, the chemicals remain unreacted and stable. Of course, this system has limits. Anyone who has struggled with an old superglue tube that hardened inside knows this isn't a perfect solution. If moisture somehow sneaks into the container over time, the glue hardens and becomes worthless. This is why superglue generally has a shorter usable shelf life than water-based glues. The story of glue is actually much older than most people realize. For thousands of years before plastic bottles existed, humans created adhesives from natural materials. Ancient civilizations used tree sap, animal collagen, beeswax, and plant resins to bind objects together. These early glues worked, but they had significant problems. Some hardened far too quickly, making them difficult to use. Others spoiled over time. Many had to be prepared fresh right before application. They were far less convenient than what we have today. The invention of synthetic adhesives during the 20th century changed everything. Researchers developed formulas that could be stored reliably for extended periods. They created glues that worked on different materials. They engineered adhesives with specific properties for specific applications. This innovation revolutionized manufacturing, construction, packaging, education, and countless other fields. Modern life as we know it depends heavily on glues and adhesives working reliably. Furniture, books, shoes, vehicles, electronics, and buildings all contain adhesives. The humble bottle of glue that sits in a desk drawer represents centuries of scientific progress and experimentation. It's a small reminder of how chemistry and physics work together to solve everyday problems in ways we barely notice. Furniture, books, shoes, vehicles, electronics, and buildings all contain adhesives. The humble bottle of glue that sits in a desk drawer represents centuries of scientific progress and experimentation. It's a small reminder of how chemistry and physics work together to solve everyday problems in ways we barely notice. A simple question about an ordinary object reveals sophisticated chemistry, and that's the beauty of discovering the science hiding in plain sight. Thank you for exploring this with us. Subscribe to uncover more secrets hiding in everyday items, and share what topics you'd like us to investigate next. Stay tuned for more stories woven through the smallest details.